Hello, testing, testing. 1, 2, 3. So what do you say? Should we give the rest of the class a little bit of time to show up? Or should we just plug on? Should we just press on? Good morning. Well, that might be as good as it gets. So there were a couple of announcements that went out in the intervening days since our last lecture, which they bear my bringing some attention to them. First of all, let me just shut myself off there. There we go. Hello. So, first of all, Assignment 8 and Test 3 grades have been released. The class average for Test 3, it turns out was like 81%, which is roughly in line. Actually, it's exactly in line with the class averages on Tests 1 and 2, which is very interesting to me. I've never had it so that all three of the tests have the same average. Of course, all of these are excluding people who did not attempt the test. In the case of Test 3, we actually had quite a large number of people MSAF it, so I guess, a third of the class or a quarter of the class all got coronavirus all at the same time and had to MSAF. So, So, as you can tell, things are kind of grinding to a close with respect to this course. We are very close to the end of the semester now, so things like the final tutorials are happening. Also, we've decided to sort of push the due date on assignment 9 and 10 a couple of days, just because, it's the end of the semester, crunch time. So you guys now have until midnight on April 12th to get that in. That is that's a 1-day extension versus its regular due date. So there you go. 1-day extension. Aha, that's for assignment 9 and for assignment 10. And aside from that, we have some important announcements about assignment 9. Ordinarily, we would get, like in previous offerings, we used the URL library to sort of do the remote access of files that's discussed in the lecture slides. However, we find that just in general, this doesn't seem to work very well. So we have essentially converted those questions to local file questions rather than remote file questions. So essentially the data files that you need to access for those can be found attached to this announcement, and I imagine also in the assignment folder on Avenue. And if you might have to refetch the Jupyter assignment folder in order to get them, but they should be there. So there you go. Cool. That one was really hard. Yeah. Well, Oh, yes, but when we make an announcement, that supersedes what's on the assignments page. So, yeah. It may say that on the assignment page, but that just means the assignment page hasn't been updated yet. So, the assignment 9 and assignment 10 are due April 12th at midnight. That is your 100% word of authority from the professor himself. So, you can take that to the bank. So, anyway, so let's continue on with the lecture material that we were covering. We were talking about databases. We didn't get very far into databases, but that's okay. So, databases. What the heck is a database? And how is it distinct from a programming language? Like programming languages, databases allow us to process and store data. However, data is stored in dedicated files and loaded as needed. The data can be much larger than the available memory, and there is no need to explicitly open files and read data. So, when you access a database, you can kind of think of database transactions as implicitly opening and closing the file all in one action. So rather than opening up the file, performing all the stuff you want to do, and then closing the file, you can think of sending a query to a database as doing all three of those things in one. This again comes back to the idea that interacting with a database is atomic. A query that you send to a database is always completely executed before the next one is. So, there you go. Databases can be accessed, quote-unquote, simultaneously by clients, either locally or remotely. So we have this issue of the sort of inherent unparallelism of computers. Because, and this distinction has been breaking down in recent years with the development of things like multi-core processors. But in general, the correct way to think of a computer is as a machine that only executes one thing at a time. So, when you've got your web browser open and you've got Solitaire running, those two processes are sharing your CPU's resources, which means, the browser gets so many cycles per second, and Solitaire gets so many cycles per second. And, part of the operating system's job is to manage which processes get how much of the CPU's time budget. Learning about that stuff particularly is I know, third or fourth year material for people in software engineering, I think. At the very least, you don't get into depth in scheduling until that. Although, I probably should more accurately say the Mechatronics program. But, so the difference with a database is because each transaction is atomic, it looks like you can have many, many people accessing a database simultaneously. In reality, you probably only have, you definitely only at some level have one operation occurring at a time, but because you can queue up operations from many users at once, it looks like all of these users are interacting with the database at the same time. And of course, from our meat space reckoning of time, to simultaneous for us means something like, in the same quarter of a second or a tenth of a second or something like that. But a tenth of a second to a computer is that's a very long time, because computers typically operate in the sort of nanoseconds range, right? That's sort of the operational time unit for a computer. So what looks like simultaneous behavior to you and I is non-simultaneous behavior for the computer, but it doesn't really matter because all we care about is the human reckoning of what's going on anyways. So, there you go. I already talked about atomic. So, the purpose for implementing database transactions as atomic is to maintain the integrity of the database itself. Database systems, by and large, are highly concerned with data integrity. We're talking things like multiple redundancies in the way that the data is actually saved. If someone loses a connection to a database, that database needs to not become corrupt as a result, because corruption in the database can be a big problem if that database is, for example, someone's financial records. So generally speaking, the relational database model that we're talking about here has been built specifically with data integrity in mind. So the other thing with databases is it's a far less flexible means of storing data. Generally speaking, if you're using relational database technologies, which are overwhelmingly they're the sort of majority shareholder with it, or whatever the term it is, the technology that is used most in the wild is relational databases. And we're going to see this, it looks pretty much like a spreadsheet. So if your data does not easily conform to this kind of spreadsheet model of data, it might be more appropriate to interact with it using a programming language. Although we have up-and-comers in the databases space that actually that use other models for data storage other than relational databases, such as JSONs. So if you remember from a couple of lectures back when we were talking about file structures, there are database clients now, database management software systems, which use JSON files as sort of the underlying storage medium for your data. So, this has advantages and disadvantages versus your traditional SQL style data storage. But it's just kind of interesting to note. And that's a reasonably recent development within the context of databasing. Yes. Also, queries are written in a dedicated query language. Let me see if we have any questions. If you don't do assignment 9 and 10 before the due date, can you still access them for study for the exam? Yes. Yes, you can. Indeed. So, in relational databases, data items and their relationships are stored in tables. A table is a collection of records, also known as rows, objects, or entities, with fields, also known as values, columns, and attributes. So, the analogy is to a spreadsheet. If you open up Microsoft Excel, you have a table presented before you that's organized into rows and columns. Generally speaking, it's not necessary to do this, but it's conventional. The columns are, various attributes. The rows are the entries, or collections of those attributes that represent, if you're doing a budget, it would be transactions. If you're doing experiments, it would be trials, this type of thing. Relational databases are organized in the same manner. And in the same way that a spreadsheet can have multiple tables, you have those table tabs along the bottom, you can click whichever one of those you wish, or, have as many of those as you wish. In the same way, relational databases also support multiple tables. And in fact, relational databases support many different types of interactions between tables, which we'll get into a little bit. So, let's imagine let's construct for ourselves a running example. Video rental store, somewhat out of date now these days, but let's cast our brains back to the 1990s. Imagine that video rental stores are still relevant, and let's make a database for one. So we want to create a database for running a video rental store. We need to keep track of A, all the movies that we have available to rent. B, we need a database of customers, like registered customers. And C, we need to know which customers have rented which movies. In order to express this, we will create a relational database with 3 tables: movies, customers, and rentals. So, here's an example of some movie data. We have 4 fields going on here. We've got a movie ID number, we've got a title, a genre, and a rating. So this brings us into the idea of a schema. So unlike spreadsheets, where, there's kind of a loose relationship between the column and the type of data that's stored in the cell, in relational databases, you need to know up front what data type each of the fields is going to be for all records. So we're in a opposition to the way things normally work in Python. We are working in a sort of static typing situation here. If you give a relational database a floating point value when it expects an integer, it will actually complain. Whereas Python will just kind of sort of try to fudge things around until it works. So we have 5 types listed here. The actual data types that will be used in any particular database management system that you may be employing is going to vary widely. There'll be some consistencies across all databases, because, it doesn't really make a lot of sense to not have a date data type, because that's a very commonly used thing. But in general, the specific implementation of the relational database is inherent in the database management software that you're using, not SQL itself as a language. You need to sort of distinguish in your brain between SQL and the database management software. Let's see, are we having a... Okay. So in the previous example, we've got these 4 fields, and the data types that we would associate with those fields are integer, text, text, and text. Notice things are named very slightly differently from how we refer to things conventionally in Python. Integers are integers, reals are floats, texts are strings, booleans are booleans, and dates are also strings. The way that databases store dates is as strings. So, yeah, in this particular example, our table's schema is exactly what I said. So now that we've sort of established some of the groundwork for what these things actually are, let's get into what SQL actually is. So SQL, or Structured Query Language, is a widely used database and query language. It's used, again, if you're going to learn a databasing language with the expectation that that will be useful for your career, it is most it is most recommended to learn SQL unless you're in a very specific sort of niche of the internet, or yeah, because MongoDB and those sorts of things are often used for internet applications. Most like traditional databasing applications will still be using SQL. So it was first proposed in 1974 for Codd's relational database model from 1970. So SQL is an old and venerable institution. It's nearly 50 years old. SQL in general, it's composed of transactions which perform modifications over the data stored in databases. So the types of interactions you can perform are fetching sets of records, adding data to tables, creating tables, deleting tables, modifying data within tables, and deleting data within tables. The syntax of SQL is mostly independent of vendor, so it doesn't really matter what database management system you're using per se. You should be on reasonably familiar ground so long as you're still using SQL. But, it is what it is. SQL also supports what we might consider to be more repository type transactions. If you don't understand this, don't worry. Such as committing and rolling back things. You can have user authorization. You can store functions, and much, much more. In fact, SQL is a lot more general than this slide deck will suggest. You can actually program in SQL in the same way that you would program in any other programming language. However, I'll always remember what one of my old math professors said to me way back in the ancient days when dragonflies were the size of minivans. When I was taking first year calculus, this professor, whose name I forget, said to me, or said to the class, sometimes it is possible to scratch your face like this, but perhaps it is preferable to scratch your face like this. So while programming in SQL is possible, it is probably more efficient to program in other programming languages, unless you're doing something very database specific. Recently, no SQL databases for storing differently structured data and cloud storage are becoming popular, among certain application bases. So I've mentioned database management systems many, many times already, because it's kind of an important thing. So essentially, how database software works is you have the SQL standard, right? And you have a whole bunch of different companies who all have different implementations of that same standard. So, in broad strokes, like pretty much all of these vendors, all of these companies who make their own implementations of SQL, since they're all working from the same standard, there will be a great degree of commonality between each one of these different database management systems. However, there will be differences. Most of the differences will probably end up being in the front end, that is, in the user experience, the user interface. But it's not necessarily the back end that's going to be as different. But, everybody has their particular one that they like, sort of thing. It's kind of like how, there are a whole bunch of different browsers, and, the primary difference between all of these different browsers is the manner in which they organize tabs and bookmarks and that sort of thing. Not the existence of tabs and bookmarks, and not the manner in which websites are displayed, but sort of these I would say aesthetic concerns. Although, but anyway. So, on the commercial side, you have things like Oracle and Microsoft SQL Server. On the open source side, you have things like MySQL/Maria Database, PostgreSQL, SQLite, and MongoDB. MongoDB I mentioned already. It's a non-SQL database. It uses JSONs as its underlying data medium. For this course, we're going to be using SQLite because it's easy, quick, simple, easy, and we can formulate queries as strings without having to worry about any user interface at all. Let me see if we have any questions. For Booleans, is it 0 equals false and 1 equals true? Yes. Like Linux, how many types of Linux are there? Oh yeah, there's like hundreds of different Linux distributions. It's a little bit different though. The way that Linux distributions evolve is more it's more of an open source model, which is like you have a implementation of, you have a Linux distribution, and some clever person is like, you know what? I really like this distribution, but I would like it so much more if, the icons spun when you clicked them or something like that. So they type up a modification to it that, that makes the icon spin, and they either release it as an add-on for the existing operating system, or, if enough of these things have accumulated, they just release it as a different operating system entirely. So you have this idea of like branching, the sort of branching and forked development of Linux. Actually, let me see here. This might be interesting. Linux families. Yeah. So, now that is quite the, oh boy. So, each one of these lines here is a Linux distribution. So, and it's got the sort of amount of time each one was supported. So, you can see that essentially what happens is you have a multiplicity of distributions that are developed, and you have lots of other ones branch off of them, and only the strong survive, as it were. So you'll notice that like a very large number of the most popular Linux distributions are based on Debian, which is still extant. Ubuntu, this is Ubuntu right here, that's also a Debian variant. You also have Red Hat. Red Hat is a major Linux family. And then you have some of the smaller ones. SUSE is one. Enoch, Arch Linux. And then you have sort of these, not necessarily, like the very small ones in there as well. And Android. Android is in there as well. So, yeah. So, in general, there's like maybe 3 or 4 big Linux families. Yeah, so that's kind of how it works. Is you have this diversification of Linux distributions in the sort of the Linux ecosystem, and in the same way that natural selection selects variants of species in the wild, users actually finding Linux distributions useful, that works to continue their support. And, you have this gradual winnowing of the different variants of distributions as they sort of as time goes on. But anyway, that's a digression on Linux. So it's a little bit different with respect to how SQL databases, how SQL software comes into being. That type of sort of multiplicity and then winnowing is sort of, it requires a freedom to access source code that is not typically found in proprietary or closed source software. So when you have someone like Microsoft design a piece of software, they don't allow people to take that code and make their own variants of it. That's what it means to be closed source software. So, it's like, this is Microsoft's software, and Microsoft makes the changes to it. So one would not say that Microsoft Access exists inside of an ecosystem. That being said, on the open source side, that is more or less how things work with open source database software. But yeah, so we're kind of getting into the weeds a little bit here on the different models of software development, but that's ostensibly something that you might be interested in if you're taking this course. Suffice to say, there's a big difference between commercial software development and open source software development. Although open source software can also be commercialized, in general, what we're talking about here is proprietary versus open source software. So, generally speaking, when you make proprietary software that implements some kind of standard, like SQL or like C or like C++ or anything like that, you have the standard, you have your engineers make something from the standard, and then you release that as a software product. The differences between different vendors' products is going to be, essentially a product of the differing philosophies and approaches of the engineers on the teams that construct the software. Largely, the sort of stealing of features is restricted by the copyright protections and trademarks and patents and intellectual property protections. Whereas in the open source movement, you have an intentional foregoing of any semblance of, you have a foregoing of the restrictive nature of intellectual property rights. Essentially, what happens in open source, like many open source licenses, will require you to, for example, attribute software to the people who originally wrote it, although you're also free to modify it. So it's like, as long as you put my name as the person who originally wrote the software in there somewhere, I'm not fussed about how you use the software. Go nuts, kid. And and that means because that software exists in a more sort of free market economy, open source software typically starts off much worse than commercial software, but like under ideal conditions, with large user bases of people who actually know how to program and can modify the code as needed, you can get extremely good open source software basically without needing to pay engineers $150,000 salaries, right? But at any rate, it's more collaborative. So, SQLite. SQLite is a widely used serverless relational database manager. You sort of have a distinction between database software that must do remote access and database software which does not do remote access. SQLite does not do remote access. That means that it's more easy to use because you can actually see the database file. You also don't have to spoof a server on your local machine in order to run it locally. It's not as efficient for large databases or multiple users. So this is, but it's very simple and good enough for this course. It's kind of like, it's like single-player mode databasing. Whereas most databases are like multiplayer mode, SQLite is one that's specifically for single-player mode. SQLite is pre-installed on Mac and Linux, as well as with Python, and it can also be downloaded from SQLite.org. So if you go to SQLite.org, in whichever your preferred browser is, you go to download, you go to precompiled binaries for Windows, you get SQLite tools. If you click this link, download that thing, open it up, extract it, you'll find SQLite is a executable inside of that, and that's how you access SQLite to be able to follow along with this lecture. For me, because I run Linux natively, all I have to do is type SQLite 3, and bling, blang, bloom, I have the SQLite prompt in the same way that I get the Python prompt. Ta-da! So, yes. So, SQLite is a command line tool, so in the same way that the Python interpreter is a command line tool, SQLite is also a command line tool. So, let's quit this and open up our video store.db. So now we've got a video store database opened in SQLite 3. So, let's create this table that we've been banging on about for some time now. In order to do that, you have to use the following command. Create table. You have to give a name for the table. We'll call it movies. And then we have to provide the schema. The schema is provided in exactly the same way as you would provide arguments to a function in Python, except you must also specify what the data type is after the name of the name that you assign to the particular field. So we have a movie ID field, movie ID, and that's an integer. We have a title, which is text. We have a genre, which is text. And we have a rating, which is text. All statements in SQL, unlike Python, must end with a semicolon. If you haven't put a semicolon there, then the statement has not ended. There are, in addition, a couple of options which modify the nature of these fields. Specifically, you can make fields required, and you can make them quote-unquote primary keys. The purpose of primary key is for all of the records in the database, in the table in the database, determining one field as a primary key tells the database software that field must be unique for every record. So, this is extremely useful if there are like ID numbers, for example. Like, for example, your student number is the primary key of your student database, your records in the student database, because everybody has a unique student number. So if we primary key that, then that's good. We can also make a field required. If you make a field required, then omitting that field will cause your query to fail. So let's make the title required. That means it must be provided whenever we create an entry. There we go. So this is cool. Now let's add some data to it. In order to insert data into a database, you use the following command. Insert into. You then have to specify the name of the table you wish to insert into, movies, and then you have to provide values and then a list of the values. So let's say 101. Casablanca. Drama, romance. Probably PG. There we go. Let's insert one more in there. Oh, incidentally, in most command line situations, if you press up on the keyboard, that will scroll up and down, will scroll you through previously entered commands. So you can modify them and continue from there, and it saves you a lot of work. If you didn't know that already. So Back to the Future is a comedy adventure, and it is also PG. Great. Now our database should now have two entries. The command for viewing a database, or viewing the information that's held in a table of a database, is select star, which stands for all, from movies. And you can see select star from and then table name just has the thing barf up everything that is contained in that table. If, for example, we only wanted to view the title and rating fields of entries in the database, we would say select title and rating from movies. And there you go. That sort of selects only that which you wish to see. Questions? Nope. Okay. Let me just pop this out and see if that's actually true. Yep. Cool. So yeah, one other note about all of these commands that I'm entering. All of these keywords that I'm entering in capital letters here, they're not actually strictly required to be entered in capital letters. However, I'm doing so in order to distinguish them visually from the sort of user-based information, right? So it's not necessary. Like you can use lowercase, select star from movies. Works fine, but it's less clear what a keyword is and what a command is, or what a identifier is. So when we get data out of a table, there are a few options that we have for the manner in which we get to view the data. I already showed you how to select specific fields from the database. You know, in this example, it's kind of trivial because we only have 4 fields in the entire database, but you can imagine a database that would have 100 fields. You know, it might... Part of the whole game of databases is seeing only that which is interesting, right? The idea with a database is you will probably have so much data inside of a database that looking through it by hand, quote unquote, can take you very, very long periods of time. This is why we use queries to look in the database rather than just rather than just scrolling through the spreadsheet. We are looking for specific things. So, let me, so we can use, well, you know what? I need to enter a few more things into this. before we can usefully do the rest of it. So, yeah. But I guess while I'm entering this, if you have any questions, please enter them into the chat now, and I will answer your questions. Data entry sucks, by the way. Which means you can probably get a job doing it, because nobody wants to do it. Because it sucks. Really helps to be able to touch type, too. That's sort of a skill I would generally recommend. If you don't know how to touch type, I highly recommend it. It's kind of criminal that they don't teach it in school anymore. There you go. Lots of populated database. Now, let's see if we have any questions. What's touch typing? If I could mime falling off my chair, I would do that. You might also know it as home row typing, but touch typing is... It's a manner of being able to use all of your fingers to touch rather than two of your fingers. Like a lot of the manner in which lots of people type if they haven't been properly trained to type is they sort of look at the keyboard and they sort of press one button at a time with their index finger, and that is highly inefficient. A trained touch typist can they place their hands on the keyboard, in your left index finger on F and your right on J, and you can hit the letter buttons without looking at them. It's since your hands are in a consistent place, you can always hit specific buttons. You can hit specific keys without needing to look for their position on the keyboard. The best hunt and peck typists that I have seen can only hit a typing speed of 25-30 words per minute, and these are people who have been doing it their entire lives. An average touch typist can hit 60 pretty consistently. A good touch typist can hit as many as 90 words per minute. So, a touch typist at the high end of touch typing is at least 3 times faster than the high end of hunting and pecking. So yeah, it's kind of like use all your fingers when you're typing. But it's a specific skill, right? You have to there's software that'll train you to do touch typing. If you're all you have to do is Google touch typing practice. There you go. Yeah. So, I think the best I ever scored on a typing speed test was 70 words per minute. So, I'm On a good day, I'm a slightly above average typist. But, for programming work, it's not necessarily like English. Programming is sufficiently dense in terms of its like semantic content that the thing that holds you back is not necessarily your typing speed. But if you're writing an essay, you know, typing speed can make a huge difference on the amount of time that you take to do anything. So, and the mere fact that I had someone in the chat asking me what touch typing is means that the school system has failed you. They were supposed to teach that to you, and they neglected their responsibility to teach you how to type in the age of computers. It's absolutely criminal, in the opinion of this particular professor. Absolutely criminal. There's nobody in the year 2021 who should not have learned touch typing in school. That is, like, it's right up there with handwriting. If you saw how I type, I probably would cry. But, the thing about touch typing is it's actually a reasonably, it's not that difficult to pick up. You just have to spend some time practicing it. Hmm. Yeah. Well, it's a specific skill, right? If you've never been taught the skill, then, it's unlikely that you'll be able to develop it naturally, right? It's like, if you're never taught how to handwrite, then it's likely you can get stuff that kind of looks a bit like handwriting, but you'll never, have nicely formed handwriting. But, yeah. Well, yeah. So, here's the test, though, right? Here's the test to see if you're a good touch typist or not. Take a sheet of paper, like plain printer paper, tape it so that it's over your keyboard, put your hands underneath the paper, and see if you can still type. Because if you can't see if you can't see the letters on the keyboard and you can still type, then you're fine. Then you're a touch typist. When I was in school, that's how they trained us on touch typing. Was they had covers over the keyboard, and you had to do typing exercises without being able to look at the letters on the keyboard. Anyway, I think that's lecture. Yep. I have my office hours immediately following this lecture. So if you have any questions pertaining to course material, please join me there. If not, I think we'll just wrap things up here, and yeah. Cool. Yeah, the thing about touch typing is, if you don't type using touch typing right now, it's nothing to feel ashamed about, It's just, think of how much more efficiently you could do your work if you could, double your typing speed, And doubling your typing speed by learning how to touch type, that is probably, you could probably do it if you took 20-minute sessions and did it for 2 weeks, you'd probably be there, I'd say. Anyway, take her easy, folks. I'll talk to you again next week, eh? There we go.